Okay. First of all, thanks so much for the invitation to participate at this interesting workshop on the topic of the innovative energy solution that it's possible to use to increase the decarbonization of the building sector. To answer to requirement to present some research on the topic of the energy module, I decided, to show you some results from my research in nearly zero energy module that I developed with a group of small medium enterprise 2 years ago in the framework of a national financing program promoted from the Tuscany region. This research was focused to develop. I am an architect for the first information for you, and so we try to develop a nearly zero energy module, an housing module that is possible to use for emergency, but also to create, a new little district around of our city. For this region, we develop a design concept with the objective to work in the frame of the reversibility in order to choose a technological solution with a low environmental impact. At the same time, to try integrate also some system to produce renewable energy and to decrease the heating and the cooling consumption of this particular module unit house. And after, we try also to choose innovative material in order to provide adequate comfort indoor performance of our residential unit. And at the end, we try also to work with a BMIM environment in order to provide the small medium enterprise involved in the research with a software that can be used to improve also the customization of the technological solution developed and also of the modular unit that we have designed together. Here you can see a section of the design concept that we have developed, where you can see that we decided to work with a platform frame technology. Is a simple wood technology that the enterprise L'Ambiente, that was the technical coordinator of this research, decided to test inside of our scientific exercise. And we decided also to integrate a smart window that you can see here, a special window where we try to integrate PV cell and other technology to produce at the same time electricity and hot water. And we try, to here you can see to work on the concept to have a modular system of about 8 square meters of surface that it's possible to assemble in an easy way to realize more big buildings, residential buildings, that it's possible to use to construct a new district around of our city. Here you can see the concept of circularity of this design concept. The idea was to provide also to our national ministry with a modular house that it's possible to use if, in Italy we have a problem with headquarters. So after an headquarters, it's very urgent to build a new district. And with this technology, it's possible also to answer to this necessity. Here you can see the kit that we have developed inside of the research in order to customize the typology of the housing that we can create with the basic module, where it's possible to integrate a different typology of windows, roofs, and material of finiture for the external surface in order to realize building with different geometrical and spatial characteristics. This concept was developed with the software BIM provided from Autodesk. So we had also tried to develop a library to provide and to share with the user in order to analyze in a very short time how can change the energy performance of the units if we change, for example, the material that we put inside of the technological envelope solution of the plant that we can integrate to provide the comfort inside of the building, and at the same time we can analyze with this software also like change the cost of the modular housing. Here you can see the project of the prototype that we have decided to realize with enterprise in order to test also in real environment how the technological solution chosen during the research activity was able to achieve the energy target of nearly zero energy consumption. And as you can see, we decided to put together two basic modules of 8 square meters of surface to create this little environment. We decide also to integrate in this prototype some plant and system to produce heating and cooling during all the year. In this slide, you can see the concept of the smart window that is another part of this research activity that we have integrated to produce electricity and hot water. It's a smart window with a frame of aluminium where are integrated three parts of three subcomponents. Two subcomponents are realized with a PV panel, and inside a metallic pipe where it's possible to have water that after the process of heating that can happen inside of this system we can use for the requirement of the users of the building. And the middle part is realized with a smart glass in order to control the heat transfer from inside to outside of the building during the winter months, and vice versa from outside to inside during the summer months. This is the technological framework of these smart windows that it's possible to integrate in the roof of our modular units. Here you can see some picture of the prototype of the windows integrated in the prototype of the housing module. You can see that we decided also to integrate other PV panels on the roof of this little prototype in order to analyze how reduce drastically the electricity requirement from the heat pump that we have integrated in the module. And here you can see the heating and cooling system equipment integrated to provide the internal comfort of the housing, in particular during the winter month. We decided to work only with an electric equipment, so we put inside of the building an heat pump and also radiant solution in order to produce the heating during the winter months. With the objective to analyze exactly what's happening inside of the prototype and to compare this result with the other results that now show you that we have developed with software in the design phase. We integrate also in the equipment and in the whole system some sensor in order to measure at the real time the comfort condition inside of our prototype. So in this slide you can see the scheme of the building management system that we have organized that is connected with data driven that is linked with another data-driven that we have inside of our research center, and so we can control at the real time the comfort inside of the prototype unit. In this slide, you can see the platform frame structure that we have used to realize the prototype. It's a simple wood technology that the enterprise Lama Ambiente that was involved in the research like coordinator usually used to realize its modular housing and commercial housing. And we decided to start from this technology to improve this technology with the use of reflecting material. Here you can see some picture of the prototype phase inside of the enterprise, and you can see also the reflecting material that we decide to analyze and use inside of this prototype in order to measure how this typology of material can help this typology of technological structure in order to improve their thermohygrometric performance. We decided to work with this innovative, I don't know if it's really innovative, but in any case in Italy is not so usually used in the prefabricate solution, insulation material like reflecting material, in order to analyze how it's possible, thanks to this material, to reduce the cost of the construction solution, but also at the same time the thickness and the weight of the building envelope, in order to underline how it's possible to realize also modular housing unit that it's possible to move from the farm to the location where it's necessary to build the new building, and without reducing the energy performance of the solution, of the housing solution. In this slide, you can see how the thermal conductivity of this material is very low if compared to the other traditional material, in particular if compared to the wood fiber insulation of mineral wool that are the usual insulation solution that the wood enterprise use in this sector of the building market. And to measure if this decision was good to achieve our objective to reduce to zero, or to try to reduce to zero the energy consumption of the building at the end of the process, we developed some energy simulation in the design phase using two software in particular. Energy Plus software in order to analyze what's happened in terms of energy consumption, and WUFI Pro software in order to analyze if the technological solution of the envelope were good to reduce the thermal loss, and at the same time to control the hygrometric performance of the facade and roof integrated in the envelope. For this reason, we developed a simulation for two climatic conditions, Munich and Palermo, so for two cities located in the North Europe and South Europe, in order to compare the results in terms of the performance for a hot and cold climatic condition, respect of different orientation of the housing module, and also respect two different technology solution of the envelope. The first one realized with APS insulation, that is a typical stratigraphy developed from the enterprise involved in the research project, and another one realized with the reflective material, that is the material that we have decided to use in this typology of framework. Here you can see, the comparison of the two typology of platform frame stratigraphy. The first one is the typical stratigraphy used from L'Ambiente. The second one is the stratigraphy developed during the project. And you can see the reflecting insulation material help us to reduce the thickness of the and also the weight of the facade and the roof components. And it's for us was very important in order also to guarantee the replicability and the mobility of the system. And here you can see some results of the first phase of simulation with Energy Plus in order to analyze the trend of temperature inside of the building module with the two stratigraphy. In blue and red, you can see the trend temperature of the inside of the module obtained with the integration of reflective material. In general, are more the trend of this temperature is more constant inside of the time that we have analyzed, and these can help us also to reduce the energy requirement for cooling and heating in the two locations, but in particular was very interesting discovered that reflective material help us to reduce the cooling requirement for the Palermo location for the South Europe, where the high temperature contributed to increase the energy consumption in general of the building, in particular of the building realized with light technology like platform frame. And here you can see how, in terms of, indoor comfort, the reflective material in both location help us, to maintain inside of the building space more adequate condition of indoor comfort in summer and in winter. And after to end, I show you some first result of the simulation of the prototype. As I told before, we decided to provide the prototype with equipment to measure the indoor condition and also the thermal loss of the envelope. And here you can see the position, for example, on the envelope of the our thermal fluximeters, and you can see how the first result of this simulation underline how the reflective material can really help us to control the thermal flow inside of the envelope solution realized with the platform frame technology. In conclusion, this research show us and help us to increase, the knowledge of the technology of platform frame, and increase also our knowledge in the field of the possibility to design innovative module housing, solution that can be used from different functional destination. But we provide with our, simulation and also measure in the real environment that the reflective insulation is a good insulation to control the indoor comfort and energy performance of the building in order to achieve the target of nearly zero energy consumption. And we hope to have the time and the possibility to continue this research in order to realize a complete housing module and to involve also the user in the, possibility to live inside of an environment realized with wood technology and smart equipment. And we this, I finish my presentation. If you have need for more information, you can visit our websites, or you can read some papers that we have, published to define and describe our research activity, or send you an email. Thanks so much, and I don't know if I have in time. Yes, let's.
Yes. Yes.
Thanks so much.
Because we have started 5 minutes later, so perfectly on time. Thank you, Rosa. As you have shared with the NSEM project, modularity and flexibility is one of the common features with the live Zero Energy Mode project, as well as the acronyms of the project. So thank you. If anyone has any question for Rosa, you can share it in the chat or ask at the end of the workshop. We will have a question and answer slot. Okay, first, our next speaker is Mitja Mori. Have I pronounced it right?
Yeah, you did. Can you hear me?
Yes.
Okay, just checking.
Clear.
Hi. So I will just share the presentation. Just a second. Okay. I'm not used with this. Okay, here it is. Okay. Can you see it?
Yes.
Okay. Hello from Ljubljana, sunny Ljubljana today, fortunately. I will present the results or the research after the project that we did together with Fundación Hydrogen Aragon back in 2020. It was finished, and it's more related to let's say, energy balances in the autarkic energy systems. We will have here the case of the Sustainhuts. That was the project focused in the mountain huts. And what we wanted with this project is to, of course, integrate with some installation in 10 mountain huts renewable energy sources, but of course, to prove that we are on the right track, we also try to assess different scenarios after the project with the research. If we not just that we make the energy systems good and reliable, but also if we reach some environmental targets, so decrease in the carbon footprint, that was the main indicator that we assessed, but also other indicators. Actually, the background was that it was the increase in the energy consumption worldwide. Fact is that energy generation is based and was based also in the mountain huts on the fossil fuels. The solution, renewable energy sources, offered a partial solution to somehow fight with this challenge. But of course, in the energy systems that are not connected to the grids, so I'm talking about the electricity grid or the natural gas grid or something else, we need some storage systems. And of course, we have to also realize that each mountain hut is a specific case, because we have different locations, we have different renewable energy sources available there, somewhere wind, somewhere just photovoltaics. But in the case of Bachimaña, a hut that that is placed in the Pyrenees in Spain, was a really specific one. Because there a lot of the hydroelectricity was available, but not used completely in the right manner. So regarding the live sustained huts that I go, let's say, a step back, that you will get a feeling of that. So we applied this to autarkic energy systems, so that is not connected to the grid. with the renewable energy sources, mainly wind, photovoltaic, and hydro were applicable. And the goal was to avoid fossil fuel consumption and also to lower environmental impact. How we did that? Of course, we have to assess energy consumption in the mountain huts, so partly with the measurements, partly also with the approach of questionnaires with the directors of these mountain huts. Then we analyzed the renewable energy potential on the specific location. We defined several topologies that we, let's say, check what it would be most appropriate to install there. And then, of course, according to that, we made an energy balance within the whole year of the operation of the mountain hut and calculate based on the energy balance and all the consumptions of the renewables and also the fossil fuel environmental impacts that arise from this operation within one year. And I also added today, but of course with a bit old data, calculation of economic parameters, because sometimes you install something that is environmentally perfect, but on other side, maybe it's very expensive. At the end of the day, you know, everything is stopped by the capex when you have to go with in the installation. So research problem was, okay, we had 10 mountain huts, but I will talk today from the Bachimaña because it's a specific case that we integrated also the possibility of hydrogen technologies to be included. So as a storage system. In other cases, maybe more relied on the let's say photovoltaic wind with combination just with the batteries, but here the potential was also to include hydrogen technologies. So you can see the Bachimaña hut is in Aragon, in Huesca, very nice city. Hi to all the friends in Huesca. I was there for 4 months and I enjoyed every moment there. So this hut is on 2,200 meters of altitude and it is 12 months of operation. That's very important because in Slovenia we have, let's say, mountain huts that are just 3 to 4 months in operation, and it's hard to install there the hydrogen technologies because you have to shut down the hut for the majority of the year, and this can degrade and you cannot, let's say, make it back to the operation. Of course, we are facing with extreme weather conditions there, and what is also important is impossible to access by road, only helicopter. So that all the, you can see here that we have basically in the beginning, we had the diesel generator and also the diesel boiler installed there. Partly was electricity was covered by the hydro power, but all the fuels had to be transported there. So the partly with the trucks and then with the helicopter to the hut. So this is environmentally not the optimal solution. So we have here year consumptions of the electricity and heat. We will see a bit later how we achieve that. At the beginning, so we have here the situation. We have the hut here, and we have the, let's say, mini hydro turbine installed there with quite a huge potential of the water. But what we found out is because of different operational constraints that are on the hydro turbine, in several months during the year, this hydro turbine could not operate because the conditions there were not appropriate with, I don't know, too much water. It was shut down. So we said, okay, but in other 10 months, we had a huge overflow of the electricity that we cannot consume. So all the electricity went with in the form of heat to the surroundings. So what we can do with that? We said, okay, we can put that in the batteries, but you know, for the mid to long term storage in the batteries, First, you need a huge amount of batteries that had to be transported there, installed, etc., conditioned, or we can install the hydrogen storage system. So with the electrolyzer, with the storage tanks, and of course the fuel cell that will convert the hydrogen back to the electricity when needed. Of course, in all the 10 months that hydro electricity is available, we have to find out how to use this electricity in the proper way. Why? Because you see here on the right side the boiler. So the Bachimaña hut was actually conditioned with the heat just with the diesel boiler. But it's very simple engineering method. If you have overflow of the electricity, install the electricity heater. So this was the first step. And then, of course, we can avoid a huge amount of diesel burn just for heating, and heating is the main issue in the hut that is on the high altitude. But on other side, we can also make possible with the storage into hydrogen to have electricity during these 3 months from the hydrogen. So what we did is, first we had to analyze what the requirements in the hut are. So you can see that electricity was measured during the 3 specific periods of the year. So these are 3, let's say, representative months that, of course, clearly because of the weather conditions have different electricity demand. And of course, on other side, we have to also obtain some assumptions. What about the heat? And you can see the heat, how it is calculated. And here, not the heat just for the heating the mountain hut, but also for the domestic water. So you need for the showers. That's why when in the summer, a lot of people are coming to Bachimaña, there is a significant demand for the heat. And these are then cumulative values from, let's say, this analytical approach within 1 year, how much electricity was consumed and how much heat was consumed. So the basic, how we will, the base or the background was how to install this. We have the hydro turbine that, of course, is linked to the mountain hut. In 3 months, we don't have this hydro turbine available, so we have to install the hydrogen technologies in between to store in the new energy vector this electricity within 10 months that we have surplus, and then use in the moments that we need in the mountain hut. So of course, what we wanted to check in this research is, okay, we can install hydrogen technologies, but what if we go just with the batteries? How this would, let's say, be at the end of the day? Is it possible also with the batteries? And we made, of course, some, let's say, experimental matrix or research matrix where we have 7 scenarios. 7 scenarios in which all the time hydropower is present, and the basic scenario is SOPV. This is state of play at the beginning. And you can see different boxes ticked here with different technologies involved. So in 4 of, I won't go in detail, but in 4 of all 7 scenarios, the hydrogen technologies are involved. And you can see just in 2 scenarios, diesel generator is involved, diesel boiler in many more scenarios. So you can see that we have also scenarios where the combination of the diesel boiler for heating and the hydrogen technologies is, or the diesel boiler with the batteries. You can see here in the last column at the beginning, in the state of play at the beginning, we had a relatively small batteries. But when we wanted to build the system that is completely related from the batteries, from the storage point of view, a huge amount of batteries in the scenario 4 had to be installed. But in the combination of the hydrogen technologies and batteries, you can see properly or decent size of the batteries, and let's say decent size of the hydrogen storage system. So we had 7 different scenarios. When we made the energy balances, we want to go with the life cycle assessment methodology to see if we made some progress also environmentally wise. And of course, the functional unit was 1 year of operation. That was the, let's say, scope. And we had the assessment with this methodology and 16 environmental impact indicators behind it. We all know carbon footprint. Carbon footprint is now in the legislation in all the parts. So let's say we will go from the carbon footprint point of view, but we can see also other indicators that are more related with the, let's say, regional impacts or the local impacts of these technologies. So these are some assumptions that I already mentioned. So the heat generation can be from current and alternative technologies, electricity also as a combination. What is important that fossil fuel consumption can be due to electricity and the heat generation. So we have diesel for the electricity generation and for heat generation. All these scenarios, all these assumptions are within these 7 scenarios. And what is important, all the fuels has to be transported there by the helicopter, vans, or trucks. So also the environmental impacts that are that arise from this transport of the fuels were included in the study. And what was also included was manufacturing process of these technologies that were installed after, so newly installed in the mountain hut. So what we wanted to show is that if you, let's say, put the technology there, that you have to somehow include also manufacturing phase of this technology. Otherwise, you can blur the environmental impacts, because you will see later it will be a huge demand of the batteries, but the hydrogen system won't be so big because the energy density in the hydrogen is much more, and it is meant for the medium to long storage better than the batteries. So we calculated and defined the energy and mass flows in all the scenarios. So you can see here for the electricity, hydropower generation, heat production at the diesel boiler for each scenario. Of course, in some scenarios, there is no heat production from the diesel boiler because the electrical boiler was installed. And also where there were no fossil fuel needed, there is no transportation. You can see in scenario 2, 3, and 6. And with this data, we went to the LCA software and we obtained the results. And you have here brief glance of these results. And the red color is bad. Red color is bad, green color is good. And what we, let's say that we won't go into 7 now different scenarios. You can see that on the right side are combined scenarios, so where we combine the batteries, the hydrogen technologies, and also in some cases some diesel in the configuration 4. But what we wanted really specifically to see is configuration 2 and 3, because configuration 2 is only battery storage without the diesel, and configuration 3 is only hydrogen storage. And we can see a huge difference toward to hydrogen system. What that means? That means that the influence of the manufacturing phase for the batteries that are a huge size to be installed there, to be able to store all the electricity within these 3 months that we need from the hydropower from the 10 months. So this manufacturing phase is influencing the overall impact totally. So in this sense, from configuration 3, 5, 6, and 7 are the best configurations that should be, let's say, researched more in detail if those configurations are feasible to realize then also in the mountain huts. Because sometimes, you know, it is possible on the paper, but in the reality, it's when you have the transportation of the storage tanks to the mountain hut, you have to know how much helicopter can carry, etc., etc. So not everything is feasible to go to the high altitude, but nevertheless, some of these scenarios were doable at the end. So if we go just to the climate change, and you can see here this difference, so the configuration 2 with only battery storage with a huge impact, but nevertheless lower as the state of play at the beginning. So it's also more favorable that we had at the beginning when we produced everything in these 3 months just from the diesel, heat and electricity. And the hydrogen system was very low because we rely more or less on the hydropower with the storage system that was not so influential in the manufacturing phase. But also these configurations 5, 6, and 7 that are combining these old technologies are favorable too. What we wanted also to check manufacturing phase of these 2 storage systems. And we can see this radar diagram that really, if you want to get quick summary of these results, bigger surface means bigger impact. And you can see manufacturing phase of the batteries needed for cover this energy storage is much bigger than the hydrogen system. Just in one case of the impact category, this is ozone depletion. This is because of some materials that are needed in the hydrogen technologies that are more damaging, but much smaller surfaces here, so it's more favorable from the manufacturing point of view. This is just the graph for the manufacturing of these 2 storage systems. And at the end, we also wanted to check really with the simple calculation of the net present cost, what that means if we include also the cash flows. And we can see that when we are targeting to the cash flow, and we would like configuration 3 because it's just the hydrogen technologies, it's not the cheapest one, of course. You can see more or less below $500,000 of installation costs. But with configuration 5 and 7, that is the combination of the diesel and hydrogen technologies, and still with a relative low carbon footprint within a whole year, we can go with better, let's say, economic solution. So just to wrap everything up, what we found out, great potential of the hydro turbine to fulfill the energy demand. So it is the case, specific case Bachimaña, but we can apply the methodology to different autarkic systems, different mountain huts. Burning of the fossil fuel, so is the processes with the higher impacts, and we have to avoid this in the mountain huts from different reasons. Also Natura 2000, not just from the general environmental impacts point of view. What was inside the research established that transportation of the fuel did not meant a big impact, so it was the small share in overall environmental impact. The burning of this fossil fuel was much more significant, and configuration with hydrogen storage system give the best results from the environmental perspective, of course. But with the batteries, we have a big environmental impact. In this case, was not appropriate to install it. So with that, I would conclude my presentation, and thank you to invite me to this workshop, and pass the word back to Fundación Hydrogen Aragon. Thank you.
Thank you, Mitja. Thanks a lot for sharing this particular case of an isolated and remote building, a mountain hut in the Pyrenees within the Sustainhuts project. The energy decarbonization of existing buildings is even more challenging than a new building, and you need to adapt to what is already in place. But there are options to apply, as you have shown us. So I invite the audience to share any questions or comments you may have in the chat. We will have a space for the speakers to answer or to share more comments, right? So we have reached the halfway point of the workshop. It's the turn of Alfredo Ortiz. Please, Alfredo. I'm not presenting any of the speakers because Pedro has already done in the welcome of the workshop, so not taking more time.
No problem. Can you see my screen?
Yes.
And hear me properly, right?
Yes.
Yes. So thank you very much. So thanks a lot to the organizing committee, first of all, for the invitation and to give me the opportunity to present some of our research group on the department. So my name is Alfredo Ortiz, and I came from the Chemical and Biomolecular Engineering Department of the University of Cantabria. And today I'm going to present one of the case study that we developed in our group, mainly focused on the sustainable and self-sufficient social home through a combined PV and hydrogen pilot. It was a pilot plant we installed here in the community autonomous of Cantabria in the framework of one of the European projects. So just let me start to give you some information about where we are located. So we are in the city of Santander in the north of Spain. So you can see how beautiful are our beaches and our place. So we have a small bay and a peninsula, and our faculty, it's 200 meters far away from the beach. So as in Ljubljana today, we have a sunny day in Santander. So we are so good, and you are invited to visit us when you want. So our department is mainly formed by 4 research groups, and our research group on advanced separation processes is focused on hydrogen technologies, on the basic research and the implementation plans, and also working on membranes for different environmental and industrial applications. So let's start with very short contextualization. As it can be seen in the climate spiral video, the global average temperature have risen by more than 1 degree since 1980, and thus the activities related to the energy generation and consumption are mainly responsible for the increase in temperature. In particular, energy used in industry and buildings contribute to more than 40% of the total CO2 emissions worldwide. So that's an important issue that we have to face. So as I commented previously, the first project that I would like to comment today was the project ZEROENERGY Puig, which was aimed at enhance energy efficiency in social and public buildings in the Sustainhuts region. The Sustainhuts regions is formed by Spain, Portugal, and the southwest of France. So we are 9 partners. The lead partner is the CTL here in Cantabria, and the main action of the University of Cantabria, it's joined with GESBICAN, which is the public administration of the social buildings here in the community region of Cantabria. So the main actions of the project are improving the energy efficiency with different strategies, with the BIM methodologies and the passive renovation systems, which were the pilot developed in France and Portugal. But here in Spain, in Cantabria, the pilot plan developed was mainly focused in the combination of renewable energies and green hydrogen as an energy storage method. So let's continue. So with this project, the University of Cantabria was responsible of the implementation of a hybrid PV hydrogen system in a social housing where 2 tenants were living since before the commissioning of the installations. So you can see here on the picture, the building and the tenant as well. So in some interviews here on the news, on the newspapers and the radio. So the idea was to initially, so we made a preliminary design plan, has been made based on the hourly consumption profile obtained through the smart meter of the electricity company. And scan Masi in the upper graph, winter and autumn are the periods with the highest consumption of the living. So it's, and in addition, the climate resources of the location has been taken into account together with the characteristics cost of the equipment. So the design of the pilot was developed on the tool Homer Pro. So just taking into account all this, the consumption of the living and the weather conditions. And in order to characterize how well was done the pilot, so we define different key performance indicators. So like term efficiency, primary energy savings, CO2 savings, and also the economic savings of the living. So they were the primary key performance indicators that we take into account of the system. So regarding the operation and how it works, our system, so we have the PV panels installed. They are directly injecting the generation energy into the inverter for supply to the home. And when we have excess of the energy from the PV panel, so they charge two buffer batteries. And in the case that we have excess, it's stored in form of hydrogen, which is generated in the electrolyzer from pre-treated water. In that case, this hydrogen is storage. So we have two small bottles of 35 bars in a medium pressure. And after that, it's compressed and accumulated in a rack of bottle at high pressure at 300 bars. When there are insufficient solar radiation and battery power, the fuel cell starts to running on the hydrogen storage, either in the buffer or in the high pressure tanks. So the fuel cell is connected to a charge regulator and supply electricity to the house via inverter and charge the battery. So all this system, it's controlled by a PLC collected all the data and the equipment and instrumentation devices to ensure the control, automation, and proper organization of the process. So finally, there are a connection to the grid to show electricity excess and cannot be stored, and also as applied as a pilot plant and a research installation. So just to ensure that the tenants have electricity all the year, if any inconvenient or any maintenance, it has to be done. So so initially, so you can see here a 3D layout of the pilot plant. Was used with Autodesk Inventor, and with a preliminary distribution of the equipment. So here as well, the first proposal of a perforated door and ventilated storage cage where the storage bottle are installed. And here you can see on the picture the final installation. On the right hand side, you can see all the system where the pilot, and on the left side, the house. On the top, you can see the PV panels installed. So we started with the commissioning of the equipment and assembled in our labs here in the University of Cantabria. So the place where it's installed is around 40 kilometers from the city of Santander. But firstly, at the university, we made the commissioning and testing all the individual equipment, so the electrolyzer, the purify system, the compressor, the fuel cell, and also the high pressure tanks. And then after that, so we made the installation on the location. And here you can see the different places, the pictures already installed on the system. So here you can see also as well the safety and control instrumentations, which are inside of the system. And here a small video where we can see here the PLC, where we can control the system, the electrical panel, the batteries, here the electrolyzer, fuel cell, and the water storage and purification. And on the ground, you can see the compressor and the perfor door and the safety system of the plant. So to carry out the monitoring and the automate processes, a SCADA system was installed, and it has access to the system with different screens that can be consulted here. So we can control from our computer here at the faculty or in everywhere from our mobile phones. So with the different screens with the relevant variables, the different automatic buttons to operate valves and other equipment, the operation variables, we can connect, disconnect, and monitoring all the values to check if everything is working properly. So going to the results and monitoring, so I will try to show you 6 different days representing the operation of the plant. The plant was operating right now for 2 years with some adjustment, and now we are implementing a digital twin of the plant in order to improve the control parameters and depending on the weather condition and also on the consumption of the house. So here you can see here 3 consecutive days in the graphs. So with different conditions. In the graph A, you can see the difference between the generation and total consumption in the 3 consecutive days, together with the evolution of the battery state of charge. And in the graph B on the bottom, so you can see the accumulated generation and consumption for each component. So the generation of energy are the PV panels, the battery discharge of the fuel cells. It's on the red colors here, and the consumers, the dryer, the compressor, electrolyzer, the home consumption, which is the main, and the exported power and the battery charge power. So the difference between this red and this blue is these blue lines on the top one. So we can see in all the cases, the difference between generation and consumer are always positive. So we have excess of energy on the day 2 and 3 with more favorable weather conditions. The battery charge rapidly with the electrolyzer be activated at 85% of the state of charge of the battery. So when the batteries are discharged until 60%, so the electrolyzer stops and the discharge rate slows down. So this is when the cases of we have a small amount of solar radiation and the electrolyzers cannot work. So we can see in these arrows, green and red. So here we can see another 3 days representatives, and here are less favorable weather conditions days. And here on the yellow bars, we can see where the fuel cell is operated. So we can see that is operated at in the morning, in the noon. So when we don't have solar radiations, and some peaks as well during the day when we have peaks of consumes in the house. In that cases, the fuel cell is activated and provide the energy that the living is needed. So as I said, so after more than 2 years of operation, so the key performance indication showed that more than 24.5 kilograms of hydrogen has been generated, and an efficiency of almost 50% has been obtained, which is in the range of the efficiencies of the electricity grid. 16,800 kilovolts hour of primary energy have been saved, and almost 2,500 kilograms of CO2 has not been emitted to the atmosphere, with an around 1,250 euros has been saved in the bills of the most disadvantaged inhabitants. So it should be noted that the pilot plant is still running and it's still monitoring and collecting the data for other different projects as well. So that's the first project that I would like to show. And now we are trying to reproduce this installation in our faculty here at the University of Cantabria. So in the framework on the second project, which is the complementary plan for energy and renewable hydrogen from the Ministry of Spain, with different action lines in that case. So we are putting installation in our faculty, and the idea is generate energy for the faculty with hydrogen, taking the excess of the PV panels that we can collect in our system, and also generate hydrogen and produce hydrogen for the different industry in our region. So we have we are a small community, but we have quite a lot chemical industry, and we identify which ones are using hydrogen in that industrial processes. And the idea is to generate green hydrogen and supply this green hydrogen to the industries in order to check if in their industrial processes are working similar or equal to the hydrogen that are buying to the hydrogen supplier companies right now. So we can see here a diagram of our system in the pilot. So we have two streams of 9 PV panels that send electricity to a hybrid inverter that charge a battery with a pack and is connected to the AC electrical panel and to the hydrogen plant. So here we can see here we have also a water purifier. We take the water from the tap, and we have the electrolyzer, 2.5 kilovolts of electrolyzer. Is a regular electrolyzer from an Apter. It's an AM electrolyzer. We have a dryer, and we ensure that we have high purity of our hydrogen. So mainly with less than 2 ppm of water, just because in some uses of the hydrogen from the industry, for example, in the rubber production, one of our company that we have close to the city of Santander, and then so we collect and store the hydrogen in different racks, and so we provide this hydrogen and we supply to the different industries. So here you can see some pictures of our systems, the 2 strings of the PV panels, the inverter, the 2 batteries as a buffer, the water purification system, the water tank module, the electrolyzer and dryer. So this is the system, the general overview with the gas pipes that are going to the storage system. So we have the SCADA, the PLC, and the different safety issues in the lab. And here you can see where is the storage system and the compressor, similar to the other installation. So just as a concluding remarks, so we can use the hydrogen technologies for decarbonization and self-sufficiency of the social housing. So it's technically feasible thanks to the renewable hydrogen-based systems. So we have to advance and progress on the prices of the technology in order to be economical viable as well. So the control system enables to proper monitoring and operating the hydrogen supply chains of the system. And now, so we are improving this control with a digital twin and using different intelligence artificials with some collaboration projects with other colleagues. And so our pilot plants have achieved remarkable milestones regarding efficiency, primary energy and emission saving, and high economic benefits. And also we include a new pilot plant in the installation of the University of Cantabria just to supply hydrogen to the university and also the industrial processes of the region and all the companies that are able to use this system. So with that, I would like to thanks again to the attendants and the organizing committee for the invitation for this talk. Thank you very much.
Thank you, Alfredo, for showing us one of the few hydrogen integration initiatives in the residential sector with such promising results. Thanks for the invitation. Cantabria is a wonderful place. You're very lucky to live there. So it's the turn of the last speaker. He's Jesus Montero, is the Director of Green Energy and Hydrogen Projects at ARPA Mobile Field Equipment, which is one of the key partners of the project, of the live ZEROENERGYMOD project. He has some issues. I have seen him connecting and disconnecting from the chat. Yeah, here we have him. Hello, Jesus, welcome. Can you hear us? He has a scheduled trip today, and that's why he's...
Yeah, okay.
Okay, can you hear us? Yeah.
Everybody, yeah.
Thank you, Jesus. The floor is yours for the presentation. I hope we don't have any technical issues to the train transport. Thank you.
Okay. So, do you mean I'm able to start?
Yes, you can share your screen and
project is a live project. It's a project which we worked together several companies. One of them was this house that is architectural office, yeah. And also we were working together ARPA's company with Hydrogen Foundation and with KUT. This is the University Defense Center for these items, yeah. And I think, well, on you can go.
Perfect.
Comprender los retos de las misiones militares y científicas en su día a día sobre el terreno es clave para fortalecerlas, sobre todo en aquellas áreas remotas donde el acceso a fuentes de energía convencionales es limitado o nulo. Si a esto además le añadimos la ubicación de la misión en climas extremos, el desafío para que las instalaciones mantengan la temperatura adecuada es mayor. En la actualidad, gran parte de las soluciones habitables instaladas en los campamentos militares no están diseñadas teniendo en cuenta la eficiencia energética. Esto consume gran cantidad de combustibles fósiles para lograr la temperatura de interior adecuada de habitabilidad. Es por ello que diseñar y fabricar módulos móviles habitables con una demanda energética casi nula sea necesario. Además, la facilidad de instalación y la modularidad, así como las opciones de aislamiento, son fundamentales. Como consecuencia de este escenario nace el Live ZEROENERGYMOD, proyecto financiado por el programa LIFE, instrumento financiero de la Unión Europea dedicado de forma exclusiva al medio ambiente y a la acción por el clima. Live ZEROENERGYMOD es un espacio habitable de fácil instalación y transporte basado en el estándar Passive House. Gran aislamiento térmico, un riguroso control de infiltraciones y una máxima calidad del aire interior. Además de aprovechar la energía del sol para una mejor climatización, reduciendo el consumo energético que incorpora fuentes de energía renovable. Esto se traduce en una significativa reducción de emisiones contaminantes. En concreto, la producción de energía se obtiene mediante placas fotovoltaicas y energía eólica. La energía sobrante generada se almacena en baterías de litio y de hidrógeno. El uso del hidrógeno como vector energético es clave para la vida dentro del módulo, ya que permite extender la autonomía energética del módulo entre 20 y 48 días. En caso de no tener aporte de energía solar o eólica, los habitantes del módulo podrían disfrutar de esta energía en reserva gracias a la producción de hidrógeno. Este sistema logra un impacto nulo de emisiones al medio y por ello es un instrumento eficaz que mitiga los efectos del cambio climático. Es por ello que el programa LIFE, el programa de la Unión Europea para el Medio Ambiente y la Acción Climática, haya apostado por este proyecto.
Fuentes renovables garantizan el suministro energético al módulo y sus excedentes se almacenan en forma de hidrógeno para garantizar el suministro durante meses. Este proyecto es pionero en la utilización de hidrógeno en edificación.
Equipos móviles de campaña ARPA lo que ha hecho en el proyecto ha sido la ejecución del mismo, la ingeniería de detalle y la hibridación de las diferentes energías renovables para que realmente se vea que tener una base militar totalmente autosostenible es posible.
Con el diseño de este sistema constructivo hemos conseguido alcanzar el gran reto de aumentar la sostenibilidad y la seguridad energética en las bases militares, disminuyendo en más de un 85% el consumo energético y cumpliendo con los estándares OTAN.
Este edificio es un hito en la construcción de edificios modulares, ya que combina la alta eficiencia energética del estándar Passive House con la máxima producción de energías renovables que le permiten ser autosuficiente en un ciclo anual de uso.
El módulo LIFE ZEROENERGYMOD tiene su demostración en la base San Jorge de Zaragoza, donde opera el Ejército Español. Y está previsto su traslado a Antártida. Se realizará una demostración en la base de investigación científica antártica Gabriel de Castilla, que cuenta con un clima extremo donde la gestión energética es crítica. Proyecto 100% aragonés, internacional y único en el mundo. El proyecto LIFE ZEROENERGYMOD, gracias al almacenamiento de energía mediante hidrógeno y producción de energía mediante placas y aerogeneradores, consigue un impacto nulo en emisiones al medio. Este modelo será útil en la construcción de soluciones logísticas diseñadas a medida para las bases de las Fuerzas Armadas Europeas, así como todo tipo de organizaciones civiles en misiones de paz, misiones de investigación, desarrollo y cooperación internacional, ONGs, empresa pública, privada o ministerio que precise desarrollar su actividad en áreas remotas. Este proyecto ha sido financiado por Programa LIFE, el instrumento de financiación de la UE en los ámbitos del medio ambiente y la acción por el clima.
Thank you, Maria. As you noticed, we were having some technical problems, issues to follow Jesus' presentation. So we are going to try to show you the current situation of the project and how is working, what is the role of the hydrogen in the energy management of the building. Okay, for doing that, Carlos Arié, coordinator of hydrogen installations at Aragon Hydrogen Foundation, is going to share just a few minutes to clarify how it's working and the hydrogen in the energy management system of the project. Thank you, Carlos, for your availability, and sorry for the short time notice.
Okay. Hello, everybody. Could you hear me?
Yes.
Okay, thank you, Paula, for your kindly presentation. I'm going to be briefly, as Paula said, we don't have much more time, but yes, we would want to show you which is the solution we prepared within the scope of this project in terms of the hydrogen management system. I'm going only, sorry, could you see my screen? Nice
yes.
work. Okay, yes. Yes, I'm going to give you a brief explanation about the ZEROENERGYMOD. The ZEROENERGYMOD is the solutions in terms of energy management system within the ZEROENERGYMOD prototype. As we have commented, or Jesus have commented in his presentation, we only have renewable energy sources just in this project. In this prototype, we have both PV panels of 5 kilowatts and 3 kilowatts wind turbine. As we are not connected to the grid, all of this energy coming from the renewable sources directly goes to the passive mode, which is the part of the module which has all the consumptions. At the moment when we have all these consumptions fed by both the PV panels and the wind turbine, and we have a surplus of renewable energies, this surplus or this excedent is used to charge the batteries. It's a daily storage system with 14.4 kilowatts hour of capacity. And at the moment that we have all the consumption in the passive mode 100% used, and also the batteries are fully charged at 100% of its capacity, we have installed a complete hydrogen system in order to try to better use this excedent of the renewable energy for those periods that we don't have energy anymore from these both sources. For this, we installed a AEM electrolyzer, a 2.4 kilowatts electrolyzer, which permits us to store hydrogen at a medium pressure up to 35 bars. Moreover, apart of this medium pressure storage, we installed both a compressor and a high pressure storage system, which allows us to store with both of those storage systems up to 8 kilograms of hydrogen, which with our estimations, it gives us more or less 20 or 30 days of autonomy without connecting to the grid to the passive mode. That's, let's say, at the moment that we have this renewable source available, but at the moment that we have not anymore this resource, if we switch off the hydrogen system, at least the electrolyzer, because we are not going to produce hydrogen at this moment. And we start to use firstly the storage, the energy coming from the batteries to feed the passive mode. It could arrive a moment that we don't have anymore these batteries with energy because it's the state of charge of them is low. So at the moment, with the hydrogen stored in both the medium and the high pressure storage, we re-electrify this hydrogen thanks to a 2.5 kilowatts PEM fuel cell in order to recharge again the batteries. Now we are going to just in 2 minutes to give you some more data about this hydrogen system. We can divide it in three areas or three subsystems. The first one is the hydrogen production. As we said, it's an AEM electrolysis technology, and its main function is to convert this excess of renewable energy into hydrogen. And the good point of this electrolyzer that we are using in this prototype is that the output pressure, the maximum output pressure is at 35 bars. After that, just in order to increase this hydrogen storage capacity, we installed an electrical compressor and a hydrogen tank, which its maximum pressure is 500 bars, but as the maximum output pressure of the compressor is 350, it allows to store us about 5 kilograms. So with both solutions, with both tanks, we have about 7.5 or 8 kilograms of hydrogen stored in the system. And finally, the fuel cell, which closes all the hydrogen cycle. And as I said, it permits us to re-electrify this hydrogen. And the main use or the use for this hydrogen is to charge the batteries. I don't know, Paula, if I just with this hydrogen presentation is enough, or we can move on the presentation. I don't know if we are out of time.
Yes, hardly out of time. Thank you, Carlos, for this quick view of the energy system that we have we have displayed in the solution, in the ZEROENERGYMOD solution, thanks to the key partner that ARPA has been in the project. I mean, we are coordinators, but ARPA is a key partner that has made it possible. Thank you, Carlos. Thank you, Jesus. We have reached the end of the presentations. The summary of the projects presented today shows the development of more sustainable energy supply technologies. It's opening a new path to ensure more efficient and integrated building energy management. We have seen that there are different approaches to energy decarbonization of buildings, but there are key points in common. One of them could be that the energy solution is, if the energy solution is modular and easily scalable, its implementation will be more flexible and more feasible within an only building, and could be applied to more buildings of diverse configurations in different locations. And another key point is that the control strategy is key to avoid oversizing of the generation and storage equipment, and therefore making the investment more expensive. So we apologize for the technical issues we have experienced, and now we open the time for the questions or any doubts or comments from the attendees, or even from the speakers about the project has been presented. You can share in the question and answer chat, or even just raise your hand and answer.
Hi, if nobody else will have it, I will have one question regarding this last presentation that is intended to be used in the military sector. I would really like to have as much data as possible, because I'm also collaborating with military sector in Slovenia, and I think this is very interesting thing. And also these modular buildings are very interesting also for the Slovenian military sector, and maybe just maybe I can somehow couple the Slovenian military defense to this project that would maybe be more outcome in the future, and maybe some future collaboration could be established.
Thank you, Mitja. The Spanish Army is not the partner of the project, but is supporting the project, being the users and allowing the project to install the solution, the modular solution in their facilities, and being as you mentioned in your presentation, it's very important to have like a long period of demonstration. So as they have been using the project for more than 2 years continuously, is helping us a lot to monitor and to identify some optimization and improvements. So yeah, the military basis is one of the applications, but it's not the only one. Actually, we are working in the project to also open to another opportunities in the civil society. But yes, we will share with you more information, and if you would like to have a dedicated meeting about the project, for sure we can talk about it. Thank you.
Thank you. Yeah, because you know these systems are expensive, and if who military has the money to invest in this, so I think it's a good opportunity also for you as an outcome of the project, that maybe you can sell your knowledge to different places, and the military is one good sector that this can be used.
Yeah, for sure. It's the sector where the project was born. I mean, it was identify the need in this sector, but it's a solution that could be applied in many other sectors. Yeah, but yeah.
Thank you.
Thank you. If it's any other question, we are.
Thank you, Paula. Thank you for. I would like also to make some questions of curiosities because it's very interesting the project that you present and had quite a lot of similarities with our project in the at least in the topology and the design of the systems. So and also it's a really challenge to move this equipment to the Antarctica with these temperatures. And how do you think that it will work in such conditions on the Antarctica? Do you think that you have to adjust some parameters or some issues or add some heaters or any other auxiliary elements for working properly on the Antarctica?
Yeah, indeed, it's a challenge to send there. The project is going to be a huge milestone in the project and afterlife project. When we were designing the module, we were taking into account the weather conditions in Riga, and it was supposed to be one of the demos of the project, but at the end it has to be cancelled because of the Ukrainian war and to be this military base would be it was very close to the Russian border. And it was the module was designed taking into account the Riga weather and also the Antarctica weather. So it's, I mean, for the weather in Zaragoza is oversized. Talking about the insulation system, and also we were to implement this exterior, this how can I say this? And to say this in Spanish, sorry, this acero inoxidable look like outside because of the pyroclastic of the Antarctica. So at that time we needed to go for the the highest top solution because of that, because it was in our plan to send it to Antarctica, but for another weather conditions, another climate, another location, the configuration and the isolation could be different. And also because of the Antarctica, at the beginning it was planned to have like a passive mode, just the habitable solution, and apart from this habitable solution, from the passive mode, will be another container with the energetic solution. But because of the Antarctica, the project decided to include the facilities and the hydrogen module inside the thermal envelope to ensure that the equipment is not getting temperatures below zero, so we can extend the life of the equipment, regarding that you are not able to change many of the equipment. You don't have an easy access to the equipment and to the module once it is in the Antarctica. So yeah, at the time of the designing, we took this into account, and we make these two main changes in the first pre-design.
So just I think I don't know if I understood properly. So currently it's already complete installed, or is the fuel cell also is installed and everything is installed? And it's yeah, okay. And when is expected to send it to the Antarctica this year, or not yet? Is there Until when
it can be this year. I mean, the project is ending this year in May 2025. So after that, it depends on the logistics plans of the Spanish Army and the Polar Committee.
Yeah.
Because they are also working on the logistics for the new scientific module. So the project will need to adapt to that logistic planification. I mean, it's not going to be a decision that we will take.
So I can imagine
alone.
that it involves a lot of things, so and a lot of permissions and etc. So it's
and the winter campaign is very short. It's only from January to March. So all the preparations need to be done like 6 months in advance.
Yeah.
Yes, and so it depends. Mainly, it depends on the logistic preparation. Maybe it's not possible to send it this year. Maybe it could be the next year. It depends on the logistics and also on the willingness of the partners of the project to send it to Antarctica at the end, or maybe in 2 years. I don't know.
Very interesting, and congratulations. We will follow the project progress. Thanks.
Thank you, Alfredo. Thank you. I would like to take this opportunity to share that we are preparing a second workshop focused on energy efficiency strategies for temporary and isolated buildings, more focused on construction techniques and consumption efficiency, aligned with what Rosa has presented today. And it will be in April. We will launch the announcement in the coming days. So if you are interested in the subject, we would love to have you. So thank you, the attendees, for their interest in the topic. And a special thank you to the speakers for their generosity and enthusiasm to share their knowledge and experience in this event. We close here these first words of the live ZEROENERGYMOD project. We hope it has been interesting and that you have learned from the innovative solutions to decarbonize the residential and housing sector. So just have a good afternoon.
Thank you very much.
Thanks so much. Bye.
Thank you. Have a nice day. Bye-bye.